Hey everyone, and welcome. Now, we've all seen those gigantic wind farms out in the countryside, right? But what if we could bring that same clean power right into the heart of our cities? Today, we're going to dive into the really fascinating and honestly pretty complex world of urban wind turbines. So, can these things really make a difference, or are they just a beautiful but kind of impractical dream? Let's find out. It's such a cool idea, isn't it? A sleek little turbine on your roof, just spinning away silently, powering your life with clean energy. But is that a realistic vision, or is it more like wishful thinking? That's the big question we are going to tackle in this explainer. So let's start with that dream. The appeal is obvious, right? Generating power exactly where we use it the most. It means cutting our reliance on a big, distant grid right here in the middle of our own concrete jungles. And the motivation behind this is crystal clear. As more and more of us pack into cities, that demand for sustainable energy just skyrockets. So the idea of tapping into the wind that's already flowing over our own buildings, well, it's incredibly compelling. But here's the thing. To make this dream a reality, you can't just shrink down one of those giant turbines from a wind farm. Nope. The city demands a totally different kind of thinking, a completely different approach to engineering. So let's take a look at the tech that's actually built for the job. Okay, so when I say wind turbine, this is almost certainly what pops into your head. The classic propeller style, the horizontal axis wind turbine, or HOT for short. It's super efficient, it's been around forever, but it's really designed for wide open spaces where the wind is strong and steady, not exactly downtown Manhattan. And this is the alternative. See how the blades on this one, the vertical axis wind turbine, or VAWT, spin around a central vertical pole? That one seemingly simple change in direction has huge implications for where and how these things can be used. These are the real stars of our urban wind story today. Now, even within the VAWT family, you've got two main flavors. Over on the left is the Savonius design. Think of it like a really fancy anemometer. Those little cups that measure wind speed. The wind literally just pushes the cups around. It's simple, it's reliable. Then on the right, you've got the Darius design. This one uses lift. Its blades are actually shaped like tiny airplane wings, generating aerodynamic lift to get it spinning. It's way more efficient, but has a funny little quirk. It can't start up on its own. This table right here, it really tells the whole story of why VAWs are the go-to for cities. They're omnidirectional, so they don't care which way the chaotic city wind is blowing. They're a lot quieter, and this is a big one. Their main parts, like the generator, are at the base. That makes maintenance so much easier and safer. No need for a massive crane in the middle of downtown, right? All right, so on paper, VAWTs seem perfectly designed for the job. But now we have to get out of the theory and into the harsh realities of the city. This is where that beautiful dream meets its first big test. And let's be honest, this is the first question anyone would ask. If my neighbor puts one of these on their roof, am I going to hear that thing whirring all day and night? It's a make or break question for any tech you want to put in a city. And the research is actually really promising. Just take a look at this graph. That red line, that's the VAT, is consistently lower than the blue line for the HAT. What that means is across most sound frequencies, the vertical axis turbine is just plain quieter. So bottom line, yeah, they are in fact much better neighbors. But here's the twist. The biggest problem isn't the turbine at all. It's the city itself. Buildings don't just block the wind, they churn it up into this chaotic, turbulent mess. You can even get these things called vortical dead spots, which are basically pockets of swirling, useless air. If you put a turbine there, it's going to do absolutely nothing. And the impact of this is it's staggering. Get this. Research shows that the difference between putting a turbine in a bad spot versus the best spot on the very same building can change the power output by a factor of 1,000. 1,000 times. See, the power in wind is related to the cube of its speed. That means just a little drop in wind speed causes a massive drop in power. Siting isn't just important, it's everything. So even if you manage to find that one perfect windy spot and you install a nice, quiet turbine, there is still one final huge question we have to deal with. Do the numbers actually add up? Well, to answer that, experts use this metric called the levelized cost of energy, or LCOE. It's a really simple but powerful idea. It just calculates the true cost for every bit of energy produced over the system's entire life. This lets you do a true apples-to-apples comparison between, say, a wind turbine and a solar panel. And Well, when researchers at TU Dublin actually ran the numbers, the conclusion was pretty stark. This quote from their 2016 study really says it all. Urban wind installations are, and I quote, difficult to justify from an economic perspective. In fact, they found that solar panels, which keep getting cheaper and cheaper, are seriously challenging whether small urban wind makes any financial sense at all.
So if the raw economics don't really work, how are these projects even getting built? Well, the answer is government support. To help speed up the green transition, countries are offering a whole mix of subsidies, tax credits, and loans to help close that financial gap. A perfect example is Germany, which set aside over 100 million euros just for these kinds of projects in 2024.
Okay, we've looked at the dream, we've looked at the technology, the tough physical realities, and the bottom line costs. So let's put it all together now and try to reach a verdict. So let's just lay it all out there. Here is the final scorecard for urban wind. On the pro side, they're quieter. They handle gusty, unpredictable wind really well. They're safer to maintain. And hey, a lot of people think they look pretty cool. But on the con side, they are less efficient than their rural cousins. Their performance depends entirely on where you put them. All that city turbulence can cause extra wear and tear. And this is the big one. They often need financial incentives to make any economic sense. So if you're seriously thinking about this for your own place, here's a super practical checklist. Step 1, measure the actual wind speed right where you want to put the turbine. Not on the ground, but up at rooftop height. Step 2, analyze the turbulence from all the buildings around you. Step 3, research every single government incentive, grant, or tax credit you could possibly get. And finally, step 4, run the LCOE numbers and compare it directly to what solar panels would cost for your property. Which brings us right back to our final question. Are these turbines a real game changer in our fight for clean urban energy? Or are they, at least for now, more of a beautiful and powerful statement, a kind of green architecture that signals a commitment to sustainability even if the pure economics are still playing catch-up? The truth, as we've seen, is complicated, and it really depends on where you stand.